Good morning, my name is Logan Wells and I am the wood science instructor for North Central Technical College. Today we're going to be working with our Wood-Mizer LT40 super hydraulic sawmill and talk through blades. You can take the guide, go ahead and bring the clamp up to it, now you can go ahead and turn it on and that will be our speed. The blade flexes down, see that as it gets to the bottom, you bring your side dust because that will create extra friction and heat that does. We're here in our grinding room to talk through what these blades are made out of. And this is a really important variable for us to understand for a couple of reasons. The first is what the blade is made out of will impact its performance and how long we'll be able to sharpen and reuse that band. And another variable is that it impacts the cost based on how much that blade will cost if it is made out of a certain alloy or material versus another. It's really important that we're using the proper material and type of band for our application. And I would encourage everyone to give our Wood-Mizer blades representative a call to talk through, is this the best type of material I should be using for my application? The first option that we have for saw blade materials is the silver tip carbon steel. Carbon steel is the most economical option for our band material. And it's a great option for whether it's high volume and resaw applications, but then also just in general, you know, it's not going to hold up as long, but you can get multiple resharpenings out of them. The next material is our double hard high alloy steel. These bands are a little bit more expensive than the silver tip, but you get twice the sharpenings. They're a great all-around, all-purpose band. It's wonderful for anything from softwoods to hardwoods. Again, all-around, all-purpose band. You will get about twice the sharpenings, twice the life out of these compared to the silver tip plain carbon steel. The next material we'll talk about is the bimetal blades. Bimetal, the name comes because we have a high alloy steel body of the blade, but then also a high-speed steel tooth. And the idea is that these blades are used for very specialty applications and high industrial, where think of it as resawing old barn beams or resawing down kiln-dried lumber, really tough, durable environments. These blades are going to last twice as long as carbon steel and really hold up quite nicely. So another material that we make our bands out of. Final material we'll talk about is the razor tip carbide steel. When we say carbide steel, if you look closely, the tips of these teeth all have a piece of carbide steel that's welded onto there. The other piece that makes this a really specialty and unique blade is what we call a triple tooth. So if you look at this tooth here, the corners are beveled compared to this tooth and this tooth. And what that does is it allows for an incredibly smooth cut that makes it great for really specialty, durable, difficult sawing applications. So think sawing tropical hardwoods, reclaimed beams again, kiln-dried lumber, or even engineered wood lumber. All those abrasive materials, this type of tooth profile and this material carbide is going to be able to provide the best milling for those really abrasive applications. One other note is because that carbide is so hard and difficult, you will need to use a diamond wheel when you're grinding and sharpening these. So again, a very unique product for those abrasive applications and a wonderful material. We're going to dive into what we call tool geometry. So when we're looking at different bands and blades, we want to understand a couple different angles that impact how that blade is going to mill the log and the lumber. We've got a diagram up here. This flat line represents the surface or end of the log, and these are our teeth as they're cutting across the surface of the wood. What's really important is that we have a 90-degree angle that goes perpendicular from the surface of the wood straight across the direction of travel. The first angle we're going to talk about is what's called the hook or rake angle. And that angle goes from that 90-degree perpendicular to the face of the tooth. That hook or rake angle can range from 4 degrees to 12 degrees. And what's important is that If we have a smaller angle, that face of the tooth is closer to that perpendicular, that's what we're going to use for very hard woods. So think oaks, frozen logs, knotty logs, not quite as aggressive, and we get more of a scraping action with the face of that tooth. On the flip side, if we have softwoods, we want a more aggressive angle. So on that 12 degrees, we're going to have a wider hook angle, and then what that does is that's more of a shearing effect. And the wood is softer, so we can mill that and machine that wood out easier. The next angle that we'll talk through is what's called the back angle or clearance angle. So again, we've got that 90 degrees from the face and the surface of the wood. That back angle goes from that surface of the wood to the back side of the tooth. That can range from 28 degrees to 39 degrees based on, again, the profile and the type of material we're cutting. If we have a larger rake angle, we're going to have a smaller back angle. And again, what's important is that these angles all add up to 90 degrees, and then the body of our tooth is that remaining amount. This back angle also determines the size, or it impacts the size of what we call the gullet. The gullet is this void space between this tooth and the next. It's kind of a U shape. And what happens is as the chips are being milled off the wood, they're stored in that gullet until the cut exits, or these teeth exit the log, and then the dust drops out the chute as the blade returns to the other side of the log to begin another cut. That gullet is very important because we want to have the proper size to hold the amount of dust or chips from when we're sawing, and we don't want to have too small of a gullet that can't hold enough dust because that will create extra friction and heat as that dust escapes the gullet. Another couple terms that impact the size of that gullet would be what we call tooth height. So we've got the base of the gullet up to the top of the tooth. That's our tooth height measurement. What's important there is to note if we have a small hook angle, we can have a taller tooth because we're not taking quite as aggressive of a bite. If we have a larger hook angle, we want a shorter tooth because we're taking a very aggressive bite into the wood. So that's very important. The last feature that we'll talk about is what's called tooth spacing. Tooth spacing goes from the point of one tooth to the point of the next tooth. And what impacts that, if we have wider tooth spacing, we're going to need a higher horsepower to be able to pull that distance and generate that shaving. If we have shorter tooth spacing, that's going to be for more resaw applications where we are taking maybe a harder, more durable product to resaw it down. Another really important variable when we're talking about bandsaw blades is the kerf. So we talked about the thickness of the band being anywhere from 38 to 50 thousandths of an inch thick. Again, that's our thickness. There's another variable that impacts that, and it's called set. So when we say set, the teeth on this blade are actually offset. If this tooth is offset to this side, this tooth is offset that side. And the reason for that is to create the space needed for that blade to run through the log and the cut without overheating and creating extra friction. So it's taking out and milling out that wood. And so how much offset as well as the thickness determines what we call kerf. Kerf is the amount of material that is created into sawdust versus lumber. So with a bandsaw, we typically have a 1/10 of an inch size kerf. This is a tooth from a circular saw. And so you can see it's much wider than our bandsaw, maybe a 1/4 inch or better. And the idea is that that wider kerf, you do need a little bit more horsepower to be able to make that cut. And then what the drawback to kerf is that the more kerf means more sawdust and less lumber. So if we can, we want a smaller kerf to be able to capture more of that log into usable material versus a byproduct in sawdust. Chainsaw mills is another example of a wider kerf compared to a thin band mill. So when we buy a fresh pack of blades, they come in two styles of packaging. This is what we call a flat pack, and as we open it up, we'll find that the bands are coiled kind of like a pretzel. Anytime we are going to be handling blades, though, we want to make sure that we have the proper PPE on. So safety glasses for sure, and then gloves once we start handling the blade so we don't cut our hands. So first step is going to be cutting our package open. As we open up the box, we'll see the teeth pointed away from us, and there's going to be a zip tie on the box. So we're going to want to cut that zip tie first. As we set that aside, we're going to take the innermost blade, so we can pull that over just to give ourselves a wiggle room at the top. We pinch that blade together so it'll fit through this little clip that we have here. Come right up, and then once it's out of that clip, we got to be really firm and control the way that blade is moving. So there is tension in the blades, but as long as you're giving a firm grip, you've got the gloves to be safe, you can fold that blade out of there. So when you buy blades, the other style of packaging that they'll come in is already pre-coiled. And we're going to go through now how you would uncoil them if you buy a square pack where they're already coiled. So first step is to give yourself plenty of space. We don't want to be uncoiling blades around other people from a safety feature. We also want to make sure we're wearing our safety glasses and leather gloves as proper PPE. So as we grab this coil, what we're looking for is the loop that hangs the lowest. So you'll notice when I have this the three coils, this loop that hangs low, it's beneath the remaining two. And so then all you need to do is with your other hand grab the back of this one, and it will open up just like that. If you grab the wrong coil, so again, we want the coil that hangs the lowest and makes that figure eight, that's the one we want. If you grab a different coil, what you'll find is it's not going to hang as low, and it'll get hung up on there. And so when you try to uncoil it, it's going to be snarled up. That's what you don't want. So if we're going to coil up a blade, again, we've got all of our PPE, safety glasses, leather gloves. And the first step we're going to do is hold the blade out. So if you picture the blade as a face of a clock, you're going to have one hand at the 7 or 8 o'clock position and one hand at the 4 or 5 o'clock position. And then the first step is going to be to flex the top of the blade down. As you see it kind of get that bend, as it gets to the bottom of the bend, you're going to bring your hands up into the middle. So you're going to flex it down and roll them in, just like that. So here's another method for coiling a blade. If you don't feel confident using the flexing method, what we can do is, again, our hands are at that 8 o'clock and 5 o'clock position. And we're going to start by putting the blade against a log or something that's safe to push against for our sawtooth. And as we kind of walk in, we're going to pull our wrists up just like we're coiling, and we're going to come on down and just fold those sides of the blade in to coil it up. A couple notes on storing blades. At the end of the day, when you're packing up or once you accumulate some dull blades, you want to make sure that you're storing blades with a purpose and a plan. So one key is to always use a piece of twine or wire to just make sure that blade doesn't come uncoiled if it gets knocked or falls on the floor or something like that. So that's step one, secure. Another really good tip that I've kind of picked up over the years is to write with a Sharpie the date that you were using that blade, maybe the pitch or style of blade, and then also if it's ready for resharp right now, or if you've got a little bit more life in it, how long you've been cutting, just those kind of mental notes. It's easier to write ahead of time versus when you're sorting through a pile of blades. We want to be conscious on where we're storing our blades, as far as don't throw them around on the floor where the teeth could get knocked up. You want to kind of keep them in a dry place that's safe. and not in a high traffic area. Another note, if we are soiling coiled blades, is to make sure that we store them back to back. So that way the teeth aren't rubbing and grinding on each other. You can store them like this and then put a piece of cardboard on the top or on the bottom if you're storing them in a box. So those are a couple key points. One question that does come up a lot of times is if there's some surface rust that appears on the blade. You will find that that surface rust is typically not a problem. Once you start cutting, that will come right off on the blade. If you are going to store blades for a long time, it's not a bad idea to just spray a light coat of WD-40 or some other kind of light oil, just to make sure that, again, if you're storing it for a long time, but generally that surface rust is not a problem. Alrighty, when it's time to change the blade, a couple key steps. First, power down the machine. So we have an electric motor, so we're going to unplug the entire mill. This is a safety procedure, lockout, tag out, make sure no accidents. Otherwise, just shut it off and take out the key, put that in your pocket. First step, gonna loosen our tension on the blade. That way we'll be able to take the blade out of there. Come around to the front, we're gonna take off these panels. So we'll start with this side one. You want to make sure, again, this is kind of a one-person job. You don't want to have too many people in here. It's a tight space, and again, with the blade, we want to just make sure we got enough room to be safe. Now that we've got the tension off, our covers off, we can then take and slide the band out and off our wheels. There we go. As we do this, we want to make sure we're not scraping our teeth as best as we can against any of the mill housing guides or the post. We're just going to kind of lift this bottom out gingerly and then roll it out. Just like that. And now we're able to coil our band. There we go. Alrighty, so now that we've got our old blade off, we'll go through the process for installing a brand new blade. So step one, again, we've got all of our panels off. We want to make sure that there's, clean out the extra sawdust. So any sawdust around the guides or the belts on the wheels, make sure that we get it clean for installing a new blade. We want to inspect the belts on the wheels to make sure that there's no frays or nicks. It's a good idea to swap out the belts from the drive side and the opposite side just so they wear evenly. So we've got her clean, we'll install our blade. So, process for this, again, we're going to take our blade and set it inside the housing. Again, want to be mindful of scratching the teeth, not the back, but the teeth against this guard or the post here. And so we're going to install it as smoothly as we can. As we go to install, we want to make sure that the blade rides in this slot and this slot here, so not underneath, but actually up in here. And then we can go and slide the band around the rest of the belt. There we go. We're going to install the band so that the bottom of the gullet is about 1/8 of an inch in front of the wheel. and that gives it so it'll ride in the proper place with this guide roller. We don't want the back of the band to be touching that, but just slightly in front. Again, you can see here we want that band to be just slightly in front of the back of that guide roller. All right. So now that we've got our blade properly positioned on the wheels, we can go ahead and put our guarding back up. But what you want to do is make sure when you're installing this, you get that little lip tight on the back of this guard, just like that. You want that to be placed right on there, and that will make it so it'll sit in there real nice. Just like that. And our last guard. We're going to tension this blade to the appropriate amount. So as we're cranking, this gauge tells us how much tension we've got on there. We're going to go to the size of our blade. So the ideal tension is 2,300 pounds per square inch. Now those blades will stretch out, so you'll tension it all the way, and then as it gets running, you'll see that tension drop. So you want to mind that, or pay attention as it's going, that you revisit and make sure you're at that proper tension level. Just retension it up a little bit again. The question often comes up, how long do saw blades last? And that really depends on what you're cutting. And there's a number of different variables that we'll talk through. In general, about 2 hours of sawing for a blade. If you're cutting really dirty logs, you might get less time than that. If you're being really purposeful and understanding how to get the most life out of your blades, you might get more time. On a manual mill, that your production might be a little lower, you can get a little more time. But it really comes down to, when do you want to change that blade? It's when you're seeing any issues with cutting. So just like using a chainsaw, sawing is really fun when you've got a sharp blade. If you're fighting a dull blade, it's just not worth it. So you want to change your blades out as soon as you see whether that's a rough cut and maybe a tooth that's marking, or if you're cutting into a knot or making wide cuts. When you're making a really wide cut in a log, or you are cutting through a knot, that's when you're first going to see that blade start to dive or move on you. Some of that could be your feed speed, making sure you're sawing at the right rate, but that's where you're going to see some issues with dull blades first. Tips on how do we make sure we have the most life out of our blades as possible. First one that I always talk about is to use sharp blades. So when you push a dull blade or a blade that's past its kind of sharp edge, you're putting extra stress and you're going to crack those blades, and you're really not going to get the most life out of them. Another really important point in getting the most life out of your blades is to be using plenty of water and lubricant. You really want to make sure that you're not running those blades dry, because that's going to create heat and friction. And so that water is helping to keep the blade cool, to keep it clean, and make sure the sawdust is exiting properly. And so as we're cutting, you always want to be using plenty of water on the blade. Another really important point in getting the most life out of your blades is to be cognizant of dirt and mud. When we're dragging logs out of the wood or around a log yard, it's not uncommon to get a little bit of mud in between the bark. And we don't want to cut through that. If you make a cut that's going through this part of the bark and you don't have a debarker, that'll really dull your blades in a hurry. So it doesn't take much when the log's up there on the mill to just go through, take a quick scan, and just knock off any dirt that you see, because just that clod of dirt will really kill your blade life. If you've got a hatchet, another really good practice is just to chip away right down in underneath that bark, and you can lift that right off. If you're Worst comes to worst, you absolutely don't have a hatchet or brush, get one, but you can put that on the back side of your cut, so you're not entering the log on that mud side, but you're exiting. That will help, but again, it's better to get a brush or a hatchet to keep your logs clean. Another note with just understanding the proper blade for the proper logs, and just log quality as that impacts the blades that you're using. So understanding the species of logs. If we are using a blade to cut up, say, spruce is a soft wood, it has needles, and the wood is fairly low density, but the knots are incredibly dense. And so what makes spruce kind of tricky to saw in some regards is that difference where you've got really soft, clean grain, and then you hit that knot or cross grain that is very dense. So we have to be really mindful when we're sawing that we are using a sharp blade with the proper pitch, and we're not overfeeding the saw when we start hitting those knots. Oak and hardwoods, what's nice about those is, yes, they are very hard. There are deciduous trees with the leaves that fall, but the wood, the straight grain and clear wood, is also of a similar density to the knots. And so we still want to be mindful when we do come into a cut with a knot that we're not overfeeding the saw, but it's more similar in density than, say, spruce would be. Logs in general, we want to make sure that we're sawing fresh logs. As they dry out, they do become more dense from a difficulty to saw standpoint, and so we got to be using a lot of lubricant to keep our blades cool, because there's just not that moisture in the log as well. Another tip for getting the most life out of your bands is to not leave them under tension when you're taking a break from sawing for a longer period of time. So if you're breaking for lunch or at the end of the day, make sure you take the tension off. Instead of being fully tight, just go ahead and loosen that down. That'll just help you get a little less, it doesn't stress the band as much, and it'll get a little more life that way. Another really important variable in getting the most life out of our blades is making sure that we actually feed them fast enough. So we want to feed the saw fast enough where the sawdust comes out kind of looking like cornmeal. If we're going too slow, what happens is the sawdust looks more like a fine flour. And the reason that's a problem is we're running the saw too slow and making fine sawdust that gets packed in the gullets and between the blade and the wood that's being cut. And the issue there is it's going to add heat and friction, and we don't want that. So we want to make sure that we're actually feeding the saw fast enough to create a little bit larger sawdust that will exit properly and allow the gullet to be doing its job versus extra sawdust getting packed around the blade. One thing you might find if you're feeding too slow or right away, the mill, you might have some washboarding. That gets back to the mill is bouncing around and it's not being fed fast enough. So you notice once I started to feed it faster, that washboarding kind of went away and we were able to get that smooth cut. So just be cognizant of how fast you're feeding the saw. And if you are going too slow, you might end up with some jostling and bumping around. So just a note there. A couple other final key points with just getting the most out of your blades. Making sure your drive belt is tensioned properly. That's something, especially with new mills, you might find that it's just not feeding or cutting right. Make sure that you've got a proper tension on your drive belt. We also want to make sure that our guides are aligned correctly and we don't have a misalignment there that could cause premature wear and tear and just not be cutting as smooth as it should be. And then lastly is our tension, making sure that we truly understand the size of our blade, the thickness, which will impact how much tension that we should have on there. And we also mentioned don't walk away or leave the blade tensioned for long periods of time when you're not cutting. So here's another perfect example when we talk about wanting to pay attention to how you're positioning the log and making sure you're not cutting through mud or dirt. So you can kind of see here, this log was laying in the ground on this side. And if I was to start the cut, so we should definitely knock off any big chunks that we see of dirt, but more so if it makes sense with the way the sawing pattern of the log should be, I want to rotate this so I'm exiting the cut with that side that it was laying on. That way any bark or mud that you can't scrape off, you're not entering and dragging it through the cut. You're more so knocking it out as that blade's returning and coming back. When we're cutting our log, especially as we start to make our first cut, one thing that will really drain our blade life is if we're taking too many excess cuts through the bark and these little skim cuts or shim cuts. So what we want to make sure we do is we're taking a proper opening face cut, and we're not making extra cuts through this bark that we don't need to for producing our lumber. Getting back to those shim cuts that we were talking about, we don't want to take extra cuts through the bark if we don't need to. And so by taking a proper opening face that was wide enough, we're able to get that usable piece we need without cutting additional passes through the bark. So that's really important, just because, again, that's where the mud, the rocks, the dirt, anything that can dull our blade is going to be in that bark. If we don't have a debarker, that's just extra wear and passes on our blade that will dull it quicker.